So all right, so let's look at chapter 6. Yeah, interrupt and timer. So this is the last chapter of our course already. And what we will learn in this chapter is the timer and interrupt in microcontroller, and how to use the interrupt on the Mbed, how to use the timer on the Mbed. Tickers and the real-time clock is actually one of the timer, and what we call the switch debouncing. Okay, let's look at the timer and interrupt also first. So to understand this interrupt and timer, so let's have this first. What we have done so far is, for example, we have a very simple application. All right, let's look at this. Here, a small-scale farming, considering a requirement for a temperature controller for mushroom growing shed, working in a cold environment. So let's, for example, we have an application like just now. So we have our microcontroller, the mushroom farm. So we have the microcontroller, and we need to monitor the temperature, for example. So we have the temperature sensor. We want to monitor the humidity, and we want to display on the so this one is the input for the microcontroller. This one is the input for the microcontroller as well. And we have the display, the LCD. Okay. So this one is the output from the microcontroller. And we have the maybe the fan. For example, if the temperature is higher than the predefined temperature, so we turn on the fan. So we have the fan. So this will be the output also. And we may have for the humidity, we have a water pump. All right. So to pump, to give water, all right, to splash water when the condition is dry, we may have input from the user. For example, want to automate manually turn on the fan or turn on the pump. All right. So this is the user input. Okay. Let's say this is temperature sensor. This is humidity. This is user input. And this is the LCD. This is the fan. This is the water pump. All right. And this is, of course, our microcontroller. So if this is our application, right, you can use this for your project as well, right? One of the application. So for this, when we want to write the program, so we need to have the flowchart for this application. So the flowchart could be looks like this. All right, you have the start, right, and you have to you do the initialization and everything. Let's ignore that. Now, first thing that you need to do is the read temperature. Read the temperature and display on the LCD. Read the temperature and display on the LCD, and then maybe you test the temperature. All right, so whether the temperature is more than the desired temperature. For example, you set 30 degrees Celsius. All right, so if more than this, you want to turn on the fan. So go here, you turn on fan, all right, and then you go back. Yeah, this is if yes, this is if no. Okay, and you test for another whether it is cold or not, right? So you can have the test. Temperature is less than, for example, 20 degree or not. All right, so if less than 20 degree already, so maybe you want to turn off the fan. Right, turn off fan, and you go back. Okay, and next you want to read the humidity. Read humidity, and you display, and again you test. Right, is it too low humid? Is it low, the humidity? So if low, maybe you need to on the water pump. Okay, if not, so if humid is high, so you may want to turn off the motor. Turn off the pump, and again you need to go back. All right, so you read these two temperature, you read the humidity, you turn on the LCD, you control the fan, you control the water pump, and what about this? So here also you need to check the input from the user. So this is user input. User input. Okay, so user input can be anything. So let's say general user input. So if yes, so we want to do this. So if yes, so we do action 1, for example, turn off the fan or whatsoever, and we need to go back. All right, and done already. So now you need to go back to the very beginning one, right? To repeat the process. Okay. So this is what we have done so far. Okay. All right. So we read the temperature and display. We test the temperature. If the temperature is more than this, we turn on the fan. But if not, we read a temperature or test the temperature for the lower limit. So if less than 20, we turn off the fan, and we test the humidity. Turn on the pump if low humid. If high humid, we turn off the pump, and we check for the user input. If got user input, we go to action 1 and so on. Okay, so that is the process that we have done so far, and also in your mini project. So when we look carefully in our flowchart, there will be two events. The first event, we can say that we can call it as periodically event. All right, where the process must be repeated, right? Is repeated. For example, you need to always read the temperature display. You need to read the humidity and display. So this is the repeated event, or periodic, or we can say the periodically event. All right, but another one is user input. User input is depend on the user, right? The user input is depend on the user. All right, this is not repeated. This is repeated but not in period. All right, means that not in the fixed time interval. This one is fixed time interval. For example, every 1 minute we want to check the temperature. Another 1 minute we want to check humidity. So every 1 minute we want to check the temperature. Every 1 minute we want to check the humidity. But the user input, all right, user input is depend on the user in whether he or she want to give the input to the microcontroller or to the system or not. So this is called user triggered event. All right, or in this case, we call it time triggered event. All right, and in this case we call event triggered. Okay, so we have two. Time triggered means that in period, in fixed time duration. Okay, and another one is external request or user triggered event. All right. Okay. All right. Any question? Can you differentiate between the two? Okay. So let's look at this. All right. So for this example, for in this table, all right, we can recognize already which one is time triggered and which one is event triggered, right? Or external triggered. So the first one is measure temperature. So this one is time triggered, time triggered every minutes, for example. Compute and implement heater and fan setting. This one, in this case, they use heater, and in my example, I use pump. All right. So this is time event, time triggered. Respond to user control. This is from user from the outside. So this is a user triggered event. All right. Record and display temperature. This is time triggered. All right. Orderly switch to battery backup in case of power loss. So this one, for example, our application got power backup mechanism. So for example, when there is power loss, so we want to change to battery. So this one is also not in fixed interval, right? This one is also will triggered by the event, not the time. Okay, so that are the difference between the two. So again, this in programming, read the temperature. All right, read the temperature, compare and turn on the fan. All right, compare, turn on the fan. We call this thing as task. All right. Okay, I need to display this. All right, I repeat, yeah. So in computer programming, in programming or in embedded programming, so this box, this box or this box we call a task. All right, it's just like an activity. All right, the things that you need to do, the things that the microcontroller need to do, the things that the computer need to do. All right, the task. So if we draw this in timeline like this, all right, time. Okay, so the process is starting like this. So the first task will be the read and display the temperature. All right, the next task will be the compare. All right, and the next will be depend on the value of the temperature. Let's say we go this way, the temperature is more than 30, so we turn on the fan. All right, another task is this. All right, so we can see that the process, the task is performed in sequence. All right, here, 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 here. Okay. So if we can perform two different tasks at the same time, that is called multitasking. Okay. But in this case, the task is performed in sequence. We read, we compare, and we turn on or we turn off, depend on the value that we compare here. All right. So now, what is the relation between this and what we want to learn later? Okay. So if we run our program in sequence like this, okay, do this, test, do this, and so on and so forth. This we call running our program in using pooling method. All right. So the task is in sequence, all right, predetermined in sequence. All right. But if our program, if our program here, when we look here, go back to here, for example, here or here, all right, when we compare, let's say, in our normal program, if the temperature is lower than 20 degree, we must go this way, right? We must go this way. But let's say in our program, when we compare, we want to interrupt our program. We want to stop our program and do something else in this point. We change the task here. All right? Do something else. Do other things. Or, for example, after this, we want to cut the flow here. We want to do something else, which is very important one. Very important one that need our microcontroller to respond immediately. All right? All right? So those are the things. Okay? How do we do that? Okay? Because in normal sequence, here we compare and here we compare and we need to do this, whether we want to turn on or turn off. Now we change this to other things. All right? We change this to respond to external event. All right. For example, we want to respond to the switch immediately. All right. Not wait until the end here. User input. All right. But according to our flow chart, this is no way, right? It's no way to do that. This is no way to do that because the microcontroller run in sequence, line by line, program by program. So if we program this way, test, if yes, we go here, if no, we go here. So there is, it looks like there is no way to do that. But with the interrupt mechanism, we can do that. All right, that's why we have interrupt method. Okay, so that is interrupt. So interrupt is we force our microcontroller or microprocessor to do this, to break any way of your program from running a normal sequence to respond to other event immediately. All right, that we call interrupt. All right, which is very important. Okay, so for example, for example, you have the your program. You design a program to for the car, for the automobile, for example. So that microcontroller will control everything, the display, the brake system, for example. So when running in normal sequence, it will check this, check this, check this. So normal sequence. So let's, for example, we want to have the automatic braking system. So when the car need to brake automatically, if you have your sequence very long and you cannot break that sequence without using the interrupt, so let's say the break checking mechanism is at the last part of your program, so it will take so long before your program check for the break. So that time, although it is only 1 millisecond, but this is very important. So your car need to respond immediately if there is a obstacle or what, so that to activate that automatic braking system. All right, so that kind of application, you need to break the sequence and respond immediately to the request for the important things. All right, so that we call the interrupt. Okay, you get the idea? All right, so that is what we want to learn in this chapter. All right, and also that is interrupt, right? So our chapter is what? Is timer and interrupt. Now what about timer? Okay, so let's look at this example. For example, we want to have a simple application like this. We have our microcontroller. Okay, connect to the 2 LED. Okay, connect to a simple LED like this. One is red color, other one is green color. Now let's write a program. Now let's write a program such that this LED blink every 0.1 second, and this LED blink every 0.2 seconds. All right, so let's do that. So when you want to start to write the program for that, okay, it's not that easy, right? Because here you see start. Okay, the first one is, okay, let's say this we call LED 1, L1. This one is L2 on L1, and we have a delay routine with 0.1 second, and now you have off. You turn off this one of L1, L1, and then you delay for another wait 1 second. Sorry, this is 0.1 second, is it? Okay, and now the problem is, because now you do this, right? And we want to do this at the same time. So when to have your L2? Where to have your L2? This is difficult, right? Because if you continue with your L2 here, just after this, on the L2 means that the sequence is not, this one is 0.1 and this one is 0.2 anymore. All right, it's just like this. When you're on L2, you're on L2, and you wait for 0.2 seconds. So you see this one L1, okay, L1 with 0.1, L1 on 0.1, off 0.1, but we have 0.2 here. For L1, we're supposed to go back and here. All right. So it's not easy to do that. Also, let's look at another example. Also, when, for example, we have a program, something like this. Start. LED also. We on L1, on L2, not on L2. We wait 10 seconds, for example. And then we want to read sensor or whatsoever. Next, huh? Read sensor. All right. So, for example, our application is something like this. So you can see that when your program is inside here, when your program is in here, you cannot do any other thing because your microprocessor is now, or your microcontroller is now do the counting process to get this wait 10 seconds. All right. So if we can do this, have the delay, and at the same time we read the sensor, which is very useful, right? Means that we can do more tasks at the same time, all right, without waiting for other tasks to finish. Okay, so that will be more useful mechanism, right? So that's why we need what we call a timer. All right, and in this case is the hardware timer. Okay, so the hardware timer is inside the microcontroller that will do the timing for you instead of writing the code for the timing. In this case, we write the code for the timing. Yeah. So the timer in this case is using software, means that we write the code for timing. So when the microcontroller do the timing, do the counting, it cannot do anything else because all the resources is for the counting. All right. But if you have the hardware timer, all right, you have the hardware timer, you can turn on this hardware timer and let the timer count. All right, this hardware timer count, and this will count independently of your program, independent of your program. So when it is timed out, for example, we set 10 seconds. So it will tell your microcontroller that, oh, 10 seconds already. So you need to do what you want to do after 10 seconds. And when the counting process is in progress, so you can do anything else. All right, because it is run independent of your program. So that we call timer. Okay, so these two things we will learn in this chapter. Okay, so you can always refer back. Huh? Okay, now we will go to the interrupt. Right, the first one is the interrupt. Okay, how the interrupt is executed. All right, before this I said that we want to do this for interrupt, where we where is it, where we break the sequence of the program execution. Okay, so we have this. Okay, how we do this, how the microcontroller, how the microprocessor and the microcontroller do this. All right, breaking the normal sequence and process the interrupt. So for this, we need to go back to what we have learned in chapter 3. The concept is similar to what we have done in subroutine, right? Okay, so the microcontroller will run the program like this, right? We know already. It is run in sequence. So where we have start, we have task 1, we have task 2, we have task 3, and so on. Okay, so the microcontroller will run the program in sequence. Exactly. Now let's say, for example, here we want to interrupt the microcontroller. Okay, so the microcontroller, we need to do something else to respond to this interrupt. So, and we as a programmer need to write the program to process that interrupt also. For example, when we want to we want to interrupt the microcontroller, what we want the microcontroller to do when we interrupt the microcontroller. So for example, this application, we go back to this application. So again, we see that this thing is run in sequence and must run in sequence, right? Read temperature, display the temperature, and read the humidity, display the humidity. So this one must be run in periodically, all right, in fixed time. But the user input, this one can be yes or no. All right, and most of the time there is no user input. We let the things run automatically. So it's better if we cut our program here. All right, don't have this in the main program. All right, and use this as the interrupt. So for example, during the normal execution here, the user press the button or give the input to the microcontroller. So we interrupt here, or interrupt here, or interrupt here. All right, so that our program is not wasting time. Keep checking the user input. So if there is no user input, our program after do this is go back to the top already. All right. So this we want to do. Okay, to change the user input to the interrupt means that the microcontroller will only respond when there is user input. Okay, so let's go back to this. Okay, so here we interrupt. So you need to write a program for the interrupt. That program is called ISR, or interrupt service routine. Okay, so for the interrupt, for example, when user press the button, give the input, or we want to immediately stop the fan. All right, off fan, and and off everything, of what, pump. And after we do all these things, we return to the main program. Okay, so you can see that the interrupt service routine is another part of the program which is not in this sequence. All right, so when you start your program, so in normal execution, it will start, execute task 1, execute task 2, execute task 3, and let's say it's go back. After this, it's go back to here. All right, execute task 3, go back, do this, do this, do this. So if there is no interrupt, your program will be running in this loop. All right, but at some point in your program, for example here, the interrupt is coming, so the microcontroller will jump to the ISR, to the interrupt, and do this thing, do this, and return to where? Return to just after the instruction, just after you interrupt. All right, so inside your microcontroller, this thing will happen. Okay, so for example, your the program in microcontroller is like this. So this is line number 1, line number 2, line number 3, 4, 5. For example, the first line you have move 0, 1. This is move 1, 2, move 1, 3, 2, 3, and so on. Let's have another one, 3, it's 4, and so on. So this is your program inside your microcontroller. So what we have learned so far is this, right? When our microcontroller execute this instruction, okay, so one thing we need to know is that the content of the PC. So let's say this is the address. These are the address. So when our microcontroller execute the instruction at address number 1, so our PC will point to the PC. What is PC? PC is program counter. Our PC will point to the next instruction, which is instruction at address number 2. When our microcontroller executing instruction number 2, the PC will point to address number 3, and so on. And let's say in our program at address 10, 11, 12, and so on is the interrupt service routine. All right, so this is our ISR. Okay, ISR is another program actually in your program memory as well, at the another location that you can set. Okay, so for example, this is any instruction in, we call it instruction 1, instruction 2, instruction 3, can be any instruction. So for example, when you execute instruction number 2, when the microprocessor executing number 2, so the PC will point to address number 3. Of course, inside the PC you have 3. Okay, now at this very moment, interrupt coming, interrupt. So the microprocessor will finish this instruction first. All right, instruction number 2. Make sure that this one finished, and the microcontroller will not execute this instruction. It will remove this, the value of PC, which is number 3, it will remove and save this value in what? In the stack, automatically, in the stack. All right. In this case, in our microprocessor, if not nested, is the LR register. All right. So this 3 will be stored here, and the microprocessor will automatically fill in PC, replace PC with the interrupt, the address of the interrupt, which is 10, so that the microprocessor can execute the interrupt. Go to number 10, do this. All right, and do this after until the return instruction. So when return, the microprocessor will move this 3 back to the PC such that, okay, 3 will go back to the PC such that your microcontroller will go back to the instruction just after you interrupt. Okay, so that is how the microprocessor execute the interrupt. Last time in the subroutine, the process is similar to this, except that the address, the subroutine, you need to call the subroutine, right? You need to call the subroutine. You need to have the instruction BL to go to subroutine. But the interrupt, no need to call the interrupt. So you can interrupt anywhere in your program. All right. So when you interrupt your microcontroller, automatically the microcontroller will finish the current instruction. All right. In this case, instruction number 2, it will finish this current instruction and replace the value of PC with the address of the ISR, which in this case is 10. All right, put 10 here so that your microcontroller will jump to the interrupt service routine and run the code in this interrupt service routine until return. All right, when return, it will get back the value that before you interrupt, the instruction that you need to execute after the interrupt. All right, which is instruction number 3. So it will put back, so the microcontroller know that after interrupt, okay, I need to do this and the next one. All right, so that is how the microcontroller or microprocessor implement the interrupt. So with this, now we can say that that is a way already for us to do this, right? Okay. So before this, just now, all right, in using the normal execution, there is no way for us to break the sequence here, right? For example, if the temperature is less than 20 degrees Celsius, you need to do this. You need to do this. But with interrupt mechanism, you can break this sequence and go back, go to other tasks, because you change the value inside the PC. All right, the microcontroller run based on the value inside the PC. All right, in sequence, because the PC is run in sequence, is increased in sequence. But if you change the value in the PC, it will force the microcontroller to jump to other location. All right, so that is the possible way to do that by using interrupt. Okay, so any question so far before we go how to the Mbed, how we implement the interrupt on the Mbed? I hope that you understand the process of interrupt first, and what is the interrupt, how the interrupt is implemented, how the process of the interrupt in the microcontroller or microcontroller processor. All right. Okay. Any question? So one more thing is that the interrupt, the ISR, you can have. Okay, good. Jeffrey, no question, yeah? Okay, good. So again, ISR. This example, you have one ISR. You can have as many as you want ISR. You can have many ISR. For example, you have ISR number 2, ISR 2, ISR 3. Okay. So this means that in your memory, in your program, you need to have ISR 1, ISR 2, ISR 3, and so on, right? So this ISR 2 may be saved in address 20. This one is address 30. So the address of this ISR is stored in the memory that we call interrupt vector, right? Okay, so the interrupt vector is the address of your interrupt service routine. ISR is interrupt service routine. Okay. So actually, you learn this ISR, the interrupt in computer architecture as well. Yeah, same concept. Okay, now let's go to the Mbed. How the interrupt is implemented on the Mbed microcontroller. So let's go back to this. Yeah, interrupt on the Mbed. So let's see what we have. So the Mbed application programming interface, the API, exploit only a small subset of the interrupt capability of the LPC 1768. All right. So some of you may ask, what is different between LPC 1768 and Mbed? Sometimes I call LPC 1768 microcontroller. Sometimes I call Mbed microcontroller. It's actually the same, except that LPC 1768 microcontroller is the chip, is the microcontroller. If we look at this, is the microcontroller. If you can see here, in if you can see this, so the LPC microcontroller is the chip here. All right, this is the full microcontroller, the full ARM Cortex M3 microcontroller, and the Mbed take this microcontroller to have this and use some of the features only, that you have connected to the pin here. All right, and name it Mbed microcontroller. So the Mbed microcontroller is this, and the core, the engine inside is the LPC 1768, and the core microprocessor core of the LPC 1768 is the ARM Cortex M3 core. All right, so that is the difference. Okay, so the Mbed give you the possibility to use the Mbed API, which is very easier as compared to program the microcontroller using without the library. So Mbed give you the library that you can straight away use the for example the digital input output, the ADC, the DAC, the PWM. But if you write the program for the LPC 1768 without the Mbed, all right, so you need to do everything, just like we did in chapter 4. To use the IO, digital IO, we need to access to the register, to turn on that, to turn off that, all right, in order to do the simple IO, all right, which is very time consuming. You need to open the manual, all right, So that is the difference lah. Okay. All right. So now let's go back to this. So the Mbed only give you some of the interrupt features that offered by LPC 1768. All right, and it is mainly focusing on external interrupt. Yeah, it gives you external interrupt only. All right, so the interrupt actually got two type of interrupt. One is internal interrupt. Second one is external interrupt. External interrupt is means that the interrupt come from the outside to the pin, to the microcontroller pin. All right, so the changes in the pin, you can set it as an interrupt input to the microcontroller. Another type of interrupt is the internal interrupt, where, for example, the ADC. All right, actually the ADC process is not that easy. We use analog in and we can read the data, the analog value, the digital representation of that analog value already. All right, using the Mbed API, analog in API. But if we don't have that library, so you need to do the initialization for the ADC. So to do that, you need to turn that control the register inside the microcontroller that control the ADC. So right, you need to turn that on. You need to do the setting, the speed of the ADC, and one thing is that inside that register there is one bit we call interrupt flag. So that flag will tell the microcontroller when the when the conversion is finished. For example, when you read the analog input, all right, so you ask the microcontroller to convert that analog input to digital. So that takes time actually to convert the digital analog to digital. So when the microcontroller convert from that analog value to digital, when the process is done, is finished, it actually give one interrupt signal to the microcontroller to tell the microcontroller that yes, the conversion is finished and the data is ready. So that we call ADC interrupt. All right, and that is interrupt, internal interrupt. All right, so there are many internal interrupt. For example, the DAC, the ADC, the serial communication also got interrupt actually to tell that microcontroller that the transmission is done and so on. The transmission is ready, is done, and so on. So that will be internal interrupt. But for Mbed, you can only use the interrupt for external interrupt, and also for timing later on. All right. Okay. The use is very flexible, as any of pin, which is very good. Any of pin 5 to 30 can be used as an interrupt input. Some of the microcontroller only give you very limited number of pin that you can use for external interrupt. For example, the PIC microcontroller, the interrupt input for external is very limited. All right, not more than 10 pins, but this one is, yes, very good, 5 to 30, except pin number 19 and 20 that you cannot use. Right, other than that you can use for external interrupt, which is very good one. So this is the interrupt API. All right, so interrupt in, very simple. So we have before this we have what? We have digital in, we have analog in, and here we have interrupt in. And this is interrupt in is digital and not analog. All right, used for digital input as well. All right, and we have rise, we have fall function, we have mode. Mode is rise is whether we want to detect at the rise time of the interrupt or the falling time of the interrupt. Mode is that whether our connection is active high or active low, depend on we want to turn on the pull up register or not. And by default is disable, means that logic 0, the pin, our pin is not connected to the pull up register, not register, sorry, resistor, not connected to the pull up resistor. So let's so the interrupt for our microcontroller. So let's, for example, this is our microcontroller. Okay, so we have the interrupt input here. Let's say we connect to P5. This is the Mbed. The signal here must be the signal that we use for the external interrupt here must be digital. So the signal, for example, come from the switch, a simple switch. All right. And this switch is connected to 3.3 volt. Give you the high when you press. And when we press, the signal that go to P5 will be something like this. All right. So here, when we not press, logic 0, and when we press, it will go to 1, press until we release. All right, until we release, it will going down to 0. So we have the option whether we want to detect the interrupt immediately here. All right, when we press, immediately it will give the interrupt to the microcontroller, or we want to have the microcontroller or to interrupt the microcontroller at the end of the press. Means that when we release, when we press and when we release here, we send the interrupt, send interrupt. This one interrupt. Okay, so here we call rise interrupt as the rise time, and here we call interrupt at the falling time or fall time. All right, that is the meaning of this rise and fall. So you have an option whether you want to detect your interrupt at the rise time or fall time of the signal, input signal. All right, so let's go back to this. Okay, so the programming is very easy, straightforward. Let's look at the programming part. So P5 we declare as interrupt in button. The name is button, and interrupt in P5, and we have 2 digital out. The first one is LED 1, the second one is LED 4. All right, means that this LED is LED built-in, the built-in LED on your Mbed microcontroller. And this is how we write the interrupt service routine. Yeah, so you need to write an interrupt service routine in another function in your program, just like the subroutine. You need to have another function, and this is your main loop, your main program. Okay, so your main program, you need to set up your interrupt and tell the microcontroller where is your interrupt. So this is how button, the name of our interrupt, button dot rise, means that we detect our interrupt at the rise time of the interrupt, and when interrupt, we will go to the ISR and we will toggle the LED, right? So if LED is 0, so we will set it 1, so it is on, and if not, if 1, we will set to 0. So that is the interrupt. If not interrupt, the normal loop, the main loop of our program is this. So what we do is we flash. So flash is LED L4. So we flash this LED every or blink this LED every 0.25 second. All right. So that is how to have a very simple interrupt application in our program. So let's see in the simulator. All right. So we will have our Mbed simulator. Okay. So this is our Mbed simulator. The default program is this. So we want this to be run in our program. So we copy and paste here, and we have another push button, right, connected to P5. Okay, so this is our push button connected to P5, and the LED is in this LED already. So can you see the LED? I'm not sure whether you can see or not because the LED is very small. If not, I will use the LED outside. If you can see, we use this LED easier. Can, okay, good. So if can, let's run the program. So let's see. Run, click run. Oh, fail. What? Why fail? Flash symbol, multiply define. Oh, okay. So the flash is maybe conflicts with the internal name of this simulator. So in the actual microcontroller, I think should be no problem. But so for this simulator, the name is used by the function inside already. So we just change the name to the flash one. Here is flash one. This one is flash one. Should be okay. So run again. All right, looks good. And we see the flash one, which is LED 4, and this is LED 4 is running flashing every 0.25 second. And when we press the button, we can see that this LED 1 is turned on because before that the state of the LED is 0 or off, because this one is not we complement not so that you get on, and when you press again it is off, you press again it is on, off. All right. So and you can see this is immediately off when I press, because this is rise time, right? If I change this to fall, you can see fall. Okay, and I run the program. Okay, if you have your computer with you, you can try this also, right? It's fun, right? Interesting. So let's see. So it is off. I press. It should, when I press, it should not on yet. So here I press. This you cannot see. Actually, I press already, and when I release, it will on. All right. So means that it is detected at the falling edge of the signal. Again, when I press, here I press already. I press. I haven't released yet. So it will still. Yeah. I press. Press. I release. When I release, it will off. Press. Not yet. Release. It will on. Press. Not yet. Release. It will off. All right. So means that it is okay. It is detected at the falling edge of the input. All right. So that is the flexibility that you can use. Okay. So let's see if we have this very long one. Let's say 5 seconds. All right. We run. Okay. And change this to rise again as ISE, sorry, run again. Okay. We can see that the LED is flashing every 5 seconds now. Very low. And we can see that this means that most of the time the microcontroller will do the wait 5. So, but when we use interrupt, anytime we can click here. All right, because it will stop and do this very fast and go back to do this thing. All right. By using interrupt, we can do this. By using interrupt, we can do this. It is possible, but without the interrupt, let's say without the interrupt. All right. How to do this application means that this one is flash every 5 seconds, and this one immediately when we press, we want this to on. So let's do this together. Means that we don't have interrupt. Instead of interrupt in, we have the digital in button P5. Okay, we don't have interrupt, so we comment all this. Comment on this. We don't have this, and we do this if button equal to 1 or button, we flash the LED, right? Flash the LED. Okay, and see what happened. Okay, you see, you press here. I press already. You can see this program won't work because when the program is inside this wait, it will not test the button. Instead, test the button. Only when you exit this wait function already. So you see, in between off or on, I cannot change. Turn this, which one? LED. I cannot change this 1 to 1. See, I press many times already. Oh yeah, that's just on. And I want to off. No, cannot. All right, because you need to wait for this function to finish. All right, to finish. So wait 5 seconds. That is 5 seconds. Is 10 seconds. Another very long way. All right. So means that it's like this. Okay. Let's explain using this. Okay. So without interrupt. Without interrupt. When you press, this is button. Which one? Button. Button, and this is LED. The flash LED 4, right? LED 4. So it will off for 5 seconds, and on for 5 seconds. All right. So when this off for 5 seconds, meaning that your microprocessor will do what? Will do the wait 5. Will be inside this function. Okay. So at this time, during this time, all right, when you push the button, when you push the button, push how many times you want, it is not respond to you because your microprocessor, your microcontroller doing this. at that time. So you press how many times? It cannot. Until you press here, it will go out to this function already and read the button. And here, the LED 1 will start to turn on. All right, and again during this time, because it go to the wait function again, so you press many times here, it will not respond to you because the microcontroller do this. All right, it's different when you use interrupt. When you use interrupt, this is LED, what LED? LED 4. Okay. For the 5 second, this is 5 second. All right. So again, same thing. When the microcontroller executing this, wait 5. Of course, the microcontroller will do the counting. All right, inside this wait 5 function, count, and count again until 5 seconds. But when you use interrupt, this is button. When you use interrupt, here you interrupt. All right. So for example, the microcontroller count from 1 to 2, 4 to 3, and here you interrupt. So the microcontroller actually will stop counting very fast one. Very fast one. Go to turn on the LED. Go to turn on the LED. This is LED 1 from 0 to 1. Turn on very fast. Turn on and go back to the counting, number 4, number 5. Because the microcontroller run very fast in less than 1 microsecond, right? Because the clock frequency is about 50 meg, if I'm not mistaken. So very fast one. So you cannot see the difference here. Okay, but it actually will stop the counting very short time. Go to turn on the LED and go back to count. That's why you can have. This. Where is this? This. So let's go back to this. See, and we have the interrupt. Enable again, and now we don't have this. Okay, 5 seconds, no problem. We press, okay, on already. We press off already. Press on, press off, no problem. It looks like not depend on this anymore. All right. That is the use of interrupt. All right. It's make your microcontroller become a multitasking device. All right. You can do two things at the same time, right? Like 2 things in the same, and then counting, and then turn off and turn on the LED. All right. So that is the interrupt. Any questions so far? And almost 12 already. I cannot finish to the timer. We have actually a lot of things need to do still. All right. So this one is slide number 16. So we have 45 slides. So I think cannot be done today. Maybe next week. All right. Or maybe I create the video for you for the rest, and next week maybe we can have a time to discuss things. And maybe the class will be on Sunday, because from Monday to Friday I have a training actually, the training course, full day from 22nd to 26th. So Monday to Friday. So Monday we cannot have the class. Maybe the class we will have on Sunday. Sunday also maybe afternoon, around 2:30, because in the morning I have master presentation. Okay, So I think for today should be enough. All right. So we have the serial communication. All of the serial communication is done for chapter 5, and we have interrupt, and the remaining part is the only the timer. Okay, any question? And remember, you need to do the assignment and also the tutorial. Yeah, try to answer the tutorial question so that we can discuss next week. Okay, if no question, we will end our class here, and see you on the Sunday. Okay, thank you very much.